So, you're an embedded engineer. That is an awesome field to be in. But let's be real, it's not always clear what the path forward looks like. How do you get from writing your first line of firmware to, architecting an entire system? Well, today we're going to map it all out step by step. This really is the big question, right? How do you actually level up from fixing little bugs to designing the whole shebang? We're going to treat your career like a strategy game. There are clear levels, new skills to unlock at each stage, and a definite path to winning. So, let's dive into the strategy. And our promise to you is simple, no guesswork. We're laying out a clear, step-by-step guide that really reflects how careers actually progress out there in the industry. By the end of this, you're going to have a solid path you can follow. Okay, so here's our plan. We're going to walk through 4 key stages of the journey, all the way from the starting line to the summit. And then we'll wrap it all up with a handy skill tree summary. Think of it as a quick reference guide for what to focus on at each level. And here it is, the entire journey, all in one place. You kick things off by building your foundation as an engineer I, and from there you can progress all the way to a principal or architect, the folks who are defining the future of entire products. You can already see how the scope just gets bigger and bigger. Let's start at the beginning. All right, you're at the starting line. Those first 2 years are all about building a rock-solid foundation. This is where all that college theory gets turned into real-world, industry-grade skills. You should think of this phase as your professional boot camp. Seriously. Your main objective isn't just to churn out code, it's to learn. You're in a guided environment, you've got seniors there to help you grow. Your mission, should you choose to accept it, is to basically be a sponge and just absorb everything you can. So what does that actually look like day to day? Well, think of your tasks as well-defined quests. You'll be writing C and C++ for microcontrollers, you'll get your hands dirty with debuggers and oscilloscopes, and you'll be implementing all those common peripherals like UART and I2C. And look, nobody expects you to know everything. The whole point is to learn by doing. So to level up, you've got to master these core skills. On the tech side, get really, really good at embedded C. I'm talking pointers, structs, the works. Get comfortable with your tools, Git, debuggers, all that good stuff. And this is crucial. Develop the soft skills of asking really clear questions and taking feedback without getting defensive. It's a game changer. This right here is your final exam for level 1. It's the single most important metric. By the time you hit year 2, can you take a small, defined feature, say reading a sensor and sending its data over UART, and implement it completely, end to end, with just a little bit of help? If the answer is yes, congratulations, you're ready to level up. Okay, so once you can build features on your own, you're ready for the next phase, gaining independence. As an engineer too, your role shifts from being a learner to being a reliable owner of your work. This is a big step. This slide really shows the core mindset shift. As an engineer 1, you were handed a specific puzzle piece. But as an engineer 2, you're handed the picture on the box, and you're expected to find, shape, and fit the pieces yourself. You're driving features from a high-level idea all the way to completion. The keyword here is ownership. It's everything at this stage. This is when your manager knows they can give you a feature and just trust that it's going to get done and get done right. You're not just a coder anymore, you're responsible for that feature's entire life, from the first design chat all the way through coding and testing. And with more ownership, you get more complex challenges. You'll be implementing entire modules, maybe a communication stack or a tricky driver. The bugs you'll hunt down are way harder now. We're talking race conditions and subtle timing issues, the really nasty stuff. And you'll start mentoring too, reviewing code from junior engineers and helping them get up to speed. So how do you know you've truly mastered this level? You become the default owner. When a specific part of the system breaks, are you the first person your colleagues ping for help? If the answer is yes, you've achieved true ownership. That's your sign. That's what tells you you're ready for the big leadership leap. All right, now we're entering the mid-career phase. This is where your focus has to expand dramatically. You're going to have to zoom out from your own code to the entire system and shift from just being an individual contributor to being a technical leader. As a senior engineer, you are now a technical leader. You're not just implementing features anymore, you're designing them. You're the one architecting major components, making those key technical decisions, and actively mentoring other engineers to lift up the whole team. Your responsibilities get a lot broader. You're tackling the absolute worst bugs, those intermittent ones that are a total nightmare to reproduce. You're writing formal design documents, and you're constantly collaborating with other teams, like hardware and QA, to make sure the entire product works together seamlessly. Your impact is officially system-wide. Now, at this stage, you often face a choice. It's kind of like a fork in the road. Do you want to go deeper technically as a senior engineer, becoming that ultimate problem solver? Or do you want to broaden your scope to lead projects and people as a lead engineer? Both are leadership roles for sure, but with a different focus. One's on system design, the other's on team execution. This is it, the summit of the technical track. When you get to this level, you're operating strategically. You're influencing not just one project, but the technical direction of the entire organization. This slide really captures that final evolution. A principal engineer shifts from a single project focus to setting the technical strategy across multiple projects. But the architect? They take it even further. They define the fundamental blueprint for entire product lines. Their decisions on hardware, software, and security can shape the company's direction for years. We have covered the entire journey. So now let's boil it all down into a quick reference guide. This is your skill tree, a summary of the key skills, tools, and project examples for every single level we just talked about. So in your early career, it is all about the fundamentals. For Engineer I, you want to master embedded C and your basic tools. A perfect project is just interfacing with a simple sensor. For Engineer 2, you're going to level up to RTOS concepts and more advanced tools so you can build something more complex, like a full peripheral driver that uses DMA. Now, in your mid-career, the skills get a bit more abstract. As a senior, you're focused on system design and using fancy profiling tools. As a lead, you're mastering project management tools like Jira and setting up CI/CD pipelines, for automated code integration and delivery so you can deliver an entire product's firmware. So there you have it, the complete career roadmap, from junior coder all the way to system architect. We've walked through the levels, the skills, and all the milestones. The only question left is, what's your next move?